So what goes into making a forecast? What we tend to do is what's called a top-down approach. So first we'll have a look at what's going on in the world right now. So we pull up the entire world observation net, and we kind of have a look at where it's raining, where it's snowing, where it has snowed, where it hasn't snowed, just all kinds of stuff that's actually happening now. Then we step it in a little bit and we look at the regional area. For instance, Charlotte. So I'm going to look at the school, for instance. I know that there's a creek valley in the middle there. So if I'm forecasting for a location at the bottom of the creek valley, it's going to be cooler down there versus it's going to be warmer, say, at the top of this hill at the McInerney building. So then we look at our upper levels and see there's a lot of wind streams up high in the air that play a huge role in the weather. So we'll look at those and we'll see, kind of make our own forecast using some atmospheric techniques that we know to kind of make a very short-term forecast about whether systems will intensify or de-intensify. And then we turn around, we compare them to the models. So we take the list of models that we know have been performing well and see which ones fall into line with this very short-term intensification check. Then, after we kind of match our forecasts with the models, we can try and decide on which models might be more inclined to be an accurate prediction of the next, let's say, 3 to 6 days. There's about a model for every different opinion there is on how the atmosphere actually functions. So to basically narrow it down some, there's regional models, and there's global models. Global models run over the entire planet, and because they do that, they run at a wider grid spacing. So the result is they can go a lot further into the future than our regional models can, but at the same time they're also much more inaccurate. Regional models step it down a little closer. They have a much higher resolution, they have much better data coverage, so what comes out of that is a better forecast in the short term. But basically all these models can go any way. It's all about how they get started. If the data coming off the Atlantic Ocean isn't that great that day, then that can have a big impact on, say, a hurricane forecast. So we definitely personalize models a little bit. A lot of these models have little quirks to them, and again, that goes back to the different physics about them. So a lot of them will tell you in a week there's going to be a major snowstorm. For instance, one of our models, the Global Forecasting System, is what's called the GFS. It spits out a snowstorm every week about this time of year. So if you look behind you, there's actually a scoreboard and a little poster up there, but we put a lot of fun in making fun of these long-range models because a lot of times they're way out there. We're talking, for instance, this GFS model sometimes will put out like 12 inches of snow for Charlotte, which of course is out of the question, at least for a 2-week forecast. As a matter of fact, last year it wanted us to have a big ice storm at some point, and that never happened.